Hi, Luke here from Technocamps again with another programming challenge, and today we're going to be talking about Russian Roulette. So Russian Roulette is a game, yeah, inverted commas, game, in which opponents load a single bullet into a chamber of a revolver and leave the other 5 blank. So there are 6 chambers in the gun, one of them has a bullet in, the other 5 are blank. You then take it in turns spinning the chamber and pulling the trigger. If the chamber lands on a bullet, you fire the bullet at the opponent and you win. But if the chamber lands on an empty, you fire a blank. You then hand over the gun to the opponent, who spins the chamber, pulls the trigger. If they miss, they hand you the gun, you spin the chamber. Okay, fairly simple. So what we want you to do is try and write a Python program which simulates Russian roulette, so that you can calculate the number of expected shots per game, as well as the relative probabilities that each player wins. So how often player 1 wins, and how often player 2 wins. And using that, you could decide if this ever was a real situation, which it won't be, if you wanted to be player 1 or if you wanted to be player 2. So the way we suggest you do it is create variables to track the number of player 1 deaths. So this would just be a running total. A second variable which will calculate would just be a running total of how many times player 2 dies, and then a total number of shots fired. When you reach the end of the program, if you divide the total number of shots fired by the number of rounds that you play, you should get an expected number of shots per round. And then during a round, you also need to keep track of whose turn it is. So if it's player 1's turn shooting, or if it's player 2's turn shooting, and if anyone has died, because you don't want your program to keep running if someone's died. You want it to stop and start again. So then inside like a for loop, we're going to repeat 1,000,000 times. I had a while loop, so while no one has died, so whilst this variable died is false, fire the gun. So choose a random chamber from 1 to 6, and increase the number of shots fired. So to choose a random number, at the start of my program, I would have imported the random library, and then I would have chosen a random number, probably using random.randint, and then 1 to 6. Then I've just got a quick if condition, so if the chamber is 6, so if the number pulled randomly was 6, the gun fires a bullet. The player whose turn it isn't dies, so we increase the counter for either player 1 or player 2. And then we set our variable of someone has died to true, so the while loop would stop and we'd start it back at the start of the for loop. If it doesn't land on a 6, then it landed on a 1, 2, 3, 4, or 5, and that's the equivalent of firing a blank, so we just swap whose turn it is in that case. Okay, it's just handing the gun over to the other person. And once this is repeated over and over and over again, so the gun swapping until someone dies, you'll exit the while loop because someone has died, and then you'll increment your for loop counter. The for loop will run again and again and again and again, over and over again, 1,000,000 times. And after that's all calculated and all done, finished, your program should then print out the probability for each player's death, as well as the average number of shots fired. So I've just run mine. So in mine, player 1 died 454,000 times, and player 2 died 545,000 times. So player 2 died more often than player 1. There's kind of like a 10% difference. And then the expected number of shots fired was roughly 6. And that kind of makes sense because we expect there are 6 chambers in the gun. If we roll a dice 6 times, we expect to get 6 roughly once. So that's kind of a good estimate. And if your numbers are similar to these, you've probably written the code properly. You could work this out analytically as well. I just haven't done it here because this is about writing programs rather than doing maths. And then as an extension, because player 1 is winning quite a lot more than player 2, we're going to change the game. So player 1 takes 1 shot, and if they miss, player 2 gets 2 shots. So they shoot once, spin the chamber. If they miss, shoot again, spin the chamber, and hand it over to player 1. Player 1 gets 3 shots, with the chamber spin in between each shot. If they miss all those shots, you hand the gun over, player 2 gets 4 shots, and so on. So that's kind of a little bit more complicated, which is why we've let it as an extension, but you should be able to calculate the probability of death for each player in a similar manner as the steps above, as well as the average number of shots fired. And you'll find if you do this that the average number of shots fired is still approximately 6. So hopefully this is approachable. It's a bit of a weird example. It's not something you'd ever come across in real life, but the maths in it and the programming is quite fun. So good luck with that, and I'm pretty sure we'll be posting solutions to most of these videos in the future, or at least my versions of the solutions. So yeah, awesome.